Everyone, this video is an exercise 11e question 1, and in this video I'm going to do part B. So in part B we have 1 plus sine x over cos x, and we want to integrate this fraction. So this section is about using integrating by substitution, or also known as U substitution. And essentially in this question we are given the substitution. So it's not always the case, but in this case we are given that use the substitution u is equal to sine x. So first of all, we write y is equal to sine x, and the first step is always differentiating the substitution. So we have du by dx is equal to sine x differentiates to cos x, and then we need to rearrange this and make dx the subject, because we want to substitute whatever we get into dx. So if we make dx the subject, then we'll have du over cos x. Also, at the same time, we also have another set of substitution, which is just substituting u whenever we see sine x in the fraction. So here we have sine x above, so we just write down 1 plus u instead of sine x. Now in denominator we still have cos x, and for dx we substitute du over cos x, and remember this here is just multiplication. Okay, so for this part, then we just simplify. So we have 1 plus u over cos squared x du, and remember that cos squared x can be written as 1 minus sine squared x. It's just an trigonometric identity. So we have 1 plus u over, so for cos squared x, we write 1 minus sine squared x du, and remember that we can substitute u into sine x. Therefore, we get 1 plus u over 1 minus u squared du. Now, the whole point of going through all these steps was to get to the point that we can easily integrate this. And this is actually very easy, because this is now reverse chain rule. So if you look at the first integral, which is 1 plus sine x over cos x, the reverse chain rule is not going to work here, because if you consider just the ln of cos x, then you won't get this plus 1 term on the numerator, so that's not just going to work there. But here it's going to work, because we can make the guess of 1 minus ln of 1 minus u squared. Now let's differentiate this. So when we differentiate, we'll get minus 2u over 1 minus u squared. Well, at this point, yeah, this is not going to work either, because I should have continued one more step actually. So yeah, that's not going to work. So we need to continue here. And the key, which I almost missed, that is the denominator is 1 minus u squared, and this can be written as 1 minus u times 1 plus u, right? Because this is an identity. This is the difference of the squares. Now at this point, this 1 plus u cancels with this 1 plus u above, and then we'll have 1 over 1 minus u du. Now this is something that we can use ln in this case. So my guess is ln of 1 minus u. Now let's differentiate this, which is minus 1 over 1 minus u. So that means we are missing a minus 1, so that they cancel, and then we get positive. So therefore here is minus ln 1 minus u plus c as the final answer. And also, this is something that I think we'd better do, because we said u is equal to sine x. So let's just substitute that here to have everything in terms of x. Minus ln of 1 minus sine x plus c.